Hello everyone, today we are going through some properties of integrals. Here we will learn to evaluate definite integrals by properties. So here these are the properties you have to study. So according to the integrand and the upper limit and lower limit, you have to apply these properties. Okay, so here integral a to b f of x dx is equal to minus integral b to a f of x dx. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Integral 0 to 2a f of x dx is equal to integral 0 to a f of x dx plus integral 0 to a f of 2a minus x dx. Okay, integral 0 to 2a f of x dx, that is equal to two results. Here if f of 2a minus x is equal to f of x, we have to first of all check if f of 2a minus x is equal to f of x, then we can say integral 0 to 2a f of x dx is equal to 2 into integral 0 to a f of x dx. Okay, and if it is f of 2a minus x is equal to minus f of x, then this integral is equal to 0. Okay, and here integral minus a to a f of x dx. Okay, in this case, if this function f of x is an even function, then this one can be written as 2 into integral 0 to a f of x dx. And if it is an odd function, then this integral is equal to 0. Okay. Now let's go through exercise 7.11. First question, integral 0 to pi by 2 cos square x dx. Here, see, first of all, let's consider it is I. Okay, let I is equal to this integral, given integral. Integral I is equal to integral 0 to pi by 2 cos square x dx. Okay. After that, here we will apply a property. We have a property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. So let's apply this property here. See, integral 0 to pi by 2. What is a here? Pi by 2. Okay. So this integral 0 to pi by 2 cos square x dx, that is equal to integral 0 to pi by 2 cos square in place of x we have to change a minus x, that is here pi by 2 minus x, pi by 2 minus x dx. Okay. Now what is it? Integral 0 to pi by 2. See, what is cos square pi by 2 minus x? What is cos pi by 2 minus theta? What is cos 90 minus theta? Sin theta, right? That is cos pi by 2 minus theta is sin theta. Cos square pi by 2 minus theta is sin square theta. So here cos square pi by 2 minus x is sin square x. Okay? Sin square x dx. Okay. So what is it? It's also I, because we have got it from this integral, right? It is I, therefore it is also I. So let's add these two integrals. Okay? So I plus I, 2I. Okay? That is equal to, see, it's also I. Okay? And this I, we adding these two integrals, that means I plus I, 2I is equal to integral 0 to pi by 2 cos square x dx plus integral 0 to pi by 2 sin square x dx. That is equal to, here our limits are same, lower limit and upper limits are same, so we can add integrands directly. So integral 0 to pi by 2 cos square x dx plus, cos square x plus sin square x dx. Okay. Now what is sin square x plus cos square x? 1, right? So this integral will become integral 0 to pi by 2 1 dx, that is equal to x. Okay. Limits 0 to pi by 2, that is equal to pi by 2 minus 0, that is pi by 2. Okay. 2i is equal to pi by 2. Actually what we have to find? We have to find integral 0 to pi by 2 cos square x dx. That is nothing but I. Okay. We have taken it as I. So what is I? 2i is equal to pi by 2. Therefore I is equal to pi by 4. So value of this integral is equal to pi by 4. That's all. integral 0 to pi by 2 root sin x divided by root sin x plus root cos x dx. See here also let's apply the same property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. So here first of all let's consider it is I. Okay. Let I is equal to this integral, given integral. Integral 0 to pi by 2 root sin x divided by root sin x plus root cos x dx. Okay. It's I. Now we will apply the property. So this integral is equal to integral 0 to pi by 2 root sin x divided by root sin x plus root cos x, that is equal to dx. Okay, that is equal to, apply the property. So it will be integral 0 to pi by 2 root of sine, in place of x we will write pi by 2 minus x, that is a minus x. Here a is pi by 2. Okay, so pi by 2 minus x, pi by 2 minus x. Okay, divided by, here also, root of sine pi by 2 minus x plus root of cos pi by 2 minus x dx. Okay, that is equal to, here, see, what is this one? Integral 0 to pi by 2 sine pi by 2 minus x, that is sine 90 minus theta, cos theta, right? Sine pi by 2 minus x is cos x. Okay, root of cos x divided by root of cos x plus cos pi by 2 minus x, sin x, right? Root of sin x. Okay, dx. Now, what is it? I, right? It is an I, and we have got it from this integral, that is I. Okay, so it's an I, it's also I. So we will add these two integrals, that is I plus I, 2i. Okay, so 2i is equal to this integral plus this integral. Integral 0 to pi by 2 root sin x divided by root sin x plus root cos x dx plus integral 0 to pi by 2 root cos x divided by this integral. Okay, root of sin x plus root cos x. Okay, dx. Then here same limits, so we can add these two integrands, right? That is equal to 2i is equal to integral 0 to pi by 2 see root sin x plus denominators are same, right? We can add directly root sin x plus root cos x divided by root sin x plus root cos x dx, right? So what is this one? 1, right? Okay, so integral 0 to pi by 2 1 dx, integral of 1 is x. Okay, and apply the limits 0 to pi by 2, that is equal to pi by 2. Okay, so here 2i is equal to pi by 2. 2i is equal to pi by 2. Actually what we have to find? We have to find I, right? This integral, value of this integral, this definite integral. It is nothing but I. Okay, so we have to find I. So what is I? I is equal to pi by 4. Okay, that is, what is I? I is equal to this one. So here we can write, hence this integral is equal to pi by 4. Evaluate integral 0 to pi by 2 sin raised to 3 by 2 x divided by sin raised to 3 by 2 x plus cos raised to 3 by 2 x dx. So here also we will apply same property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, so for that first of all let's take it as I. Okay, so let I is equal to integral 0 to pi by 2 sin raised to 3 by 2 x divided by sin raised to 3 by 2 x plus cos raised to 3 by 2 x dx. Okay, now we will apply the property. So this integral is equal to integral 0 to pi by 2 sin raised to 3 by 2 x divided by sin raised to 3 by 2 x plus cos raised to 3 by 2 x dx, that is equal to integral 0 to pi by 2. Here we have to change, that is in place of x pi by 2 minus x. Okay, So sine raised to 3 by 2 pi by 2 minus x divided by sine raised to 3 by 2 pi by 2 minus x plus cos raised to 3 by 2 pi by 2 minus x dx. That is equal to, here we know that sine pi by 2 minus x is cos x. So sine raised to 3 by 2 pi by 2 minus x is cos raised to 3 by 2 x, right? So here 0 to pi by 2 cos raised to 3 by 2 x, okay, divided by here also cos raised to 3 by 2 x plus it will be sine, right? Sine pi by cos pi by 2 minus x is sin x, right? So cos raised to 3 by 2 pi by 2 minus x is sine raised to 3 by 2 x, okay? Sine raised to 3 by 2 x dx, okay? So what is it? I itself, right? So we have got it from this one, this integral, that is I. So this I, we will add these two integrals, that is I plus I, 2I, right? So 2I is equal to, add these two integrals, integral 0 to pi by 2 sine raised to 3 by 2 x divided by, okay, let's add it directly. So because limits are same, 0 to pi by 2, here also 0 to pi by 2. So we can write sine raised to 3 by 2 x plus cos raised to 3 by 2 x, okay, divided by, and the denominators are same, so we can add it directly, okay, sine raised to 3 by 2 x plus cos raised to 3 by 2 x dx. What is it? 1, right? So integral 0 to pi by 2 1 dx, that is integral of 1 with respect to x is x and limits 0 to pi by 2, apply the limit, so pi by 2, okay? 2I is equal to pi by 2. What is this integral? It is I, right? So I is equal to pi by 4. 2I is equal to pi by 2, I is equal to pi by 4. So the value of this integral is pi by 4. Integral 0 to pi by 2 cos raised to 5x divided by sin raised to 5x plus cos raised to 5x. Same property we will apply here. Okay, that is equal to, okay, so first of all let's take I is equal to integral 0 to pi by 2 cos raised to 5x divided by sin raised to 5x plus cos raised to 5x dx. So this property is very important, okay? Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, okay? So here let's write this, apply the property, integral 0 to pi by 2 cos raised to 5x divided by sin raised to 5x plus cos raised to 5x dx. That is equal to, apply the property, integral 0 to pi by 2. In place of x, we will write pi by 2 minus x. Cos raised to 5 pi by 2 minus x divided by sin raised to 5 pi by 2 minus x plus cos raised to 5 pi by 2 minus x dx. Okay. That is equal to, here it will be integral 0 to pi by 2. Cos raised to 5 pi by 2 minus x is sin raised to 5x, okay, divided by, it is cos x, cos raised to 5x plus sin raised to 5x dx. So it's also I, we will add these two integrals, I plus I, 2I. 2I is equal to integral 0 to pi by 2 cos raised to 5x, denominators are same, right? So we will add numerator cos raised to 5x plus sin raised to 5x divided by, okay, cos raised to 5x plus sin raised to 5x divided by, what is the denominator? Sin raised to 5x plus cos raised to 5x dx. Okay. So here, see, value is 1, right? So it is 1. So this integral 0 to pi by 2 1 dx, integral of 1 dx is x 0 to pi by 2, that is equal to pi by 2. So 2I is equal to pi by 2, I is equal to pi by 4. integral minus 5 to 5 modulus x plus 2 dx. See how to define modulus function. Modulus x plus 2 is equal to x plus 2 when if x plus 2 greater than 0, right? That is x greater than minus 2. Okay. Modulus x plus 2 is equal to minus of x plus 2 if x plus 2 less than 0. That is if x less than minus 2. So here we have a property integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. Here c is a less than c less than b. Okay, so here also minus 2, we have got a point, that is minus 2, minus 5 less than minus 2 less than 5, right? So here we can write it as integral minus 5 to minus 2, okay, integral minus 5 to minus 2 f of x dx, that is modulus x plus 2 dx, okay, plus integral minus 2 to 5, okay, integral minus 2 to 5 f of x, that is modulus x plus 2 dx, okay. And here see modulus x plus 2 is equal to x plus 2 when x greater than minus 2. When here where is x greater than minus 2? Here, right? That is minus 2 to 5. Here x greater than minus 2. Okay, because minus 2 to 5 means increasing, right? So here minus 5 to minus 2, that is this range is nothing but minus 5 to minus 2. So it is less than, x is less than minus 2. So here it is minus modulus x plus 2 is equal to minus of x plus 2 when x less than minus 2. Okay. So here this function is minus integral minus 5 to minus 2 x plus 2 dx. Okay, or you can write minus x plus 2. Okay, plus here it is plus itself, right? Integral minus 2 to 5 x plus 2 dx. Now integrate it. Here minus of x plus 2, x plus 2 means, or you can integrate it separately or directly you can integrate x plus 2, take it as x, okay. So x plus 2 whole square divided by 2, right? X plus 2 whole square divided by 2. So it's not 4, 2, okay. That is x square by 2. The integral of x is x square by 2. Here x plus 2, so x plus 2 whole square divided by 2. Plus here, what is the limits? Minus 5 to minus 2. Okay. Plus here also x plus 2 whole square divided by 2 minus 2 to 5. Now let's apply the limits. Substitute upper limit then lower limit. Okay. So minus of, here it will be minus 2 plus 2 0. Okay. Put x is equal to upper limit, that is minus 2. So minus 2 plus 2 0. So first term will be 0. Okay. 0 minus, next we will apply, we will substitute lower limit, minus 5 plus 2 minus 3, minus 3 square is 9, 9 by 2, right? Minus 9 by 2. Okay, minus 3, that is minus 5 plus 2 minus 3, minus 3 square is 9, 9 by 2. Plus here also apply, so first of all let's put x is equal to 5, 5 plus 2, 7, 7 square is 49, okay, 49 divided by 2, minus, next let's put lower limit, x is equal to minus 2, it will be 0, minus 2 plus 2, 0, okay. So here it will be minus into minus plus, 9 by 2 plus 49 by 2, that is equal to 58 divided by 2, that is 29. Evaluate integral 2 to 8 modulus x minus 5 dx. Similar problem. So here also we will apply the same property. So first of all let's define this. Modulus x minus 5, that is equal to x minus 5 when x minus 5 greater than 0. Okay, that is x greater than 5. Okay, take 5 here, so it will be x greater than 5. Modulus x minus 5 is equal to minus of x minus 5 if x minus 5 less than 0, that is x less than 5. Okay. So here we know that it is 2 less than 5 less than 8. Okay. So here we can write this integral. We will apply the property integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. So this integral is equal to integral 2 to 5. Here what is c? 5, right? 2 to 5 modulus x minus 5 dx plus integral 5 to 8 modulus x minus 5 dx. Okay. And here see what is the function? Modulus x minus 5 is equal to plus x minus 5 when x greater than 5. Where is x greater than 5? Here, right? See here integral limits are 5 to 8. 5 to 8 means 5 less than x less than 8. So here x is greater than 5. So when x is greater than 5, it is positive. And next see modulus x minus 5 is equal to minus of x minus 5 when x less than 5. See this integral limits 2 to 5, that is 2 less than x less than 5. See here x less than 5. Okay. So when x less than 5, this modulus x minus 5 is equal to minus of x minus 5. Okay. So this function we can write minus of integral 2 to 5 x minus 5 dx. Okay. Because modulus x minus 5 is equal to minus of x minus 5 when x less than 5. Here x less than 5. Here range is 2 to 5. Okay. Plus here plus itself integral 5 to 8 x minus 5 dx. Now let's integrate it. That is minus of x minus 5 whole square. Integral of x is x square by 2. So here x minus 5 whole square by 2. Okay. Limits 2 to 5. Plus here also x minus 5 whole square by 2. Limits 5 to 8. Okay, now let's substitute upper limit and lower limit. That is minus of here. See, first of all, we have to substitute upper limit, that is 5. Put x is equal to 5. This first term will be 0. Right? 5 minus 5, that will be 0. Okay, 0. Minus lower limit. Put x is equal to 2. 2 minus 5 is minus 3. Minus 3 square is 9. 9 by 2. Okay? So, 9 by 2. Plus here. Next term, first we will substitute upper limit, that is 8. Put x is equal to 8. 8 minus 5, 3. 3 square is 9. 9 by 2. Okay, 9 by 2. Minus, next we will substitute lower limit, x is equal to 5. X is equal to 5, when we substitute x is equal to 5, it will be 0. Right? 5 minus 5 is 0. Okay, 0. So the value is minus into minus plus. So 9 by 2 plus 9 by 2, that is 18 divided by 2, that is equal to 9. Evaluate integral 0 to 1 x into 1 minus x whole raised to n dx. See, it's in the form of integral 0 to a f of x dx. Okay, we will apply the property integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay, so let's apply this property. So this integral is equal to integral 0 to n x into 1 minus x whole raised to n dx, that is equal to integral 0 to 1. Okay, in place of x we will write a minus x, f of a minus x. Here a is 1, right? So 1 minus x. So 1 minus x into, okay, in place of x we should write 1 minus x. And it will be 1 minus x whole raised to n dx. Okay, that is equal to integral 0 to 1 minus x into, here 1 minus 1 cancelled, minus into minus plus x. So plus x raised to n dx. Okay, so here this can be written as 1 minus x integral 0 to 1 x raised to n into 1, expand this, x raised to n into 1 x raised to n minus x raised to n into x raised to n plus 1. See, now we can integrate it directly, right? So here that is equal to integral 0 to 1. Okay, let's integrate it. First here integral 0 to 1 x raised to n dx. What is the integral of x raised to n? x raised to n plus 1 divided by n plus 1. Okay. That is x raised to n plus 1 divided by n plus 1 minus, what is the integral of x raised to n plus 1? X raised to n plus 2 divided by n plus 2, right? X raised to n plus 2 divided by n plus 2. Why? X raised to n plus 1 divided by n plus 1 plus 1, that is n plus 2. Okay. So what is the limit? 0 to 1. Okay. Now let's substitute the limits. First of all, we have to substitute upper limit. Okay. Put x is equal to 1. So this will become 1 raised to n plus 1, that is 1 itself. So 1 divided by 1 n plus 1. Okay. N plus 1. Here we have to substitute the upper limit and lower limit values for x. Okay. So here put x is equal to 1. 1 raised to n plus 1 is 1. 1 divided by n plus 1 minus, again here also upper limit, 1 raised to n plus 2, that is 1 divided by n plus 2. Okay. Minus, see, when we substitute x is equal to 0, this whole terms will be 0, right? 0 raised to n plus 1, 0. So 0 by n plus 1, 0. This will be 0. Okay. So here 1 by n plus 1 minus 1 by n plus 2, take LCM. So it will be n plus 2 minus n plus 1 divided by n plus 1 into n plus 2, that is equal to, here n minus n cancelled, 2 minus 1 is 1. Okay. 1 divided by n plus 1 into n plus 2. It is the answer. It's very important question. Evaluate integral 0 to pi by 4 log of 1 plus tan x dx. It's also very important question. So here also we will apply the same property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. So here integral 0 to pi by 4 log of 1 plus tan x dx, that is equal to integral 0 to pi by 4 log of 1 plus, in place of x we will write pi by 4 minus x. Okay. Tan pi by 4 minus x dx. Okay. See here next, integral 0 to pi by 4 log of 1 plus, see what is this one? Tan of pi by 4 minus x, that is tan x minus y. What is tan of x minus y? Tan x minus y is equal to tan x minus tan y divided by 1 plus tan x into tan y, right? We have learned it in trigonometric functions, right? Tan of x minus y is equal to tan x minus tan y divided by 1 plus tan x into tan y. So here we will write it as 1 plus tan pi by 4 minus tan x, okay, tan x minus tan y divided by 1 plus tan pi by 4 into tan x dx. Okay, that is equal to integral 0 to pi by 4 log of 1 plus, here see what is tan pi by 4 value? 1, right? So it will be 1 minus tan x divided by 1 plus 1 into tan x, that is 1 plus tan x, right? Dx. Okay. Then let's take LCM, cross multiply. Okay. That is equal to integral 0 to pi by 4 log of 1 plus tan x into 1, that is 1 plus tan x plus 1 minus tan x divided by 1 plus tan x dx. That is equal to, see here tan x minus tan x cancelled, tan x minus tan x cancelled, 1 plus 1 2, integral 0 to pi by 4, 1 plus 1 2, log of 2 divided by here 1 plus tan x dx, right? That is equal to, see here it's in the form of log of x divided by y, log of x by y. So what is log x by y? Log x minus log y, right? So here we can write it as integral 0 to pi by 4 log 2 minus log 1 plus tan x dx. Okay, log 2 minus log of 1 plus tan x dx. Now let's split it, integral. Now let's split this integral. This integral is equal to integral 0 to pi by 4 log 2 dx minus integral 0 to pi by 4 log of 1 plus tan x dx. Right? Okay. So what is this one? See here. This integral. Okay. So first of all, okay, we should take I is equal to this integral. Okay. So if it is I, it's also I. Right? We have taken I is equal to integral 0 to pi by 4 log of 1 plus tan x dx. Right? So we have got the same integral here. Same limits also. Okay. So here it is nothing but I. Okay. So this integral is equal to integral 0 to pi by 4, that is I is equal to, okay, we have got this from this one, right? So here I is equal to integral 0 to pi by 4 log 2 dx minus, what is it? I. Okay, I. Next we will take this I left side. So it will become I plus I, that is 2I. 2I is equal to integral 0 to pi by 4 log 2 dx. See here, log 2 is a constant, right? So we can take it outside. So log 2 into integral 0 to pi by 4 1 dx. That is equal to, what is the integral of 1? X. So log 2 into x, limits are 0 to pi by 4. That is equal to log 2 into x minus, that is pi by 4 minus 0. Okay, pi by 4 minus 0, that is pi by 4. Okay, so here log 2, pi into log 2 divided by 4. Pi into log 2 divided by 4. What is it? It is 2i. Okay, we need to find this integral. It is nothing but I, right? So I is equal to, so what is I? I is equal to, it is divided by 2, right? So pi log 2 divided by 4 divided by 2, that is 8. Okay, so pi log 2 divided by 8, that is I. Okay, the value of this given integral is pi log 2 divided by 8. Integral 0 to 2 x into root of 2 minus x dx. So here also given definite integral is of the form integral 0 to a f of x dx. Integral 0 to a f of x dx, that is equal to integral 0 to a f of a minus x dx. Right? Let's apply this property. So here this integral is equal to integral 0 to 2, in place of x we will write 2 minus x. Okay, here a minus x, a is 2, so 2 minus x into root of 2 minus x dx, right? That is equal to integral 0 to 2, 2 minus x into 2 minus 2 cancelled, so minus minus become plus, so here it will be x, okay, only x, so root x dx, right? Now let's expand it. So here it will be integral 0 to 2, 2 into root x, 2 root x minus x into root x dx. Okay, now we can integrate it, right? Okay, that is integral 0 to 2 into, here we can take 2 outside. So root x is x raised to 1 by 2 dx minus integral 0 to 2 x into root x into x raised to 1 by 2, that is x raised to 3 by 2 dx. Okay, that is 2 into, here x raised to 1 by 2 is, integral of x raised to 1 by 2 is x raised to 3 by 2 divided by 3 by 2. X raised to 3 by 2 divided by 3 by 2, limits 0 to 2. Minus, here x raised to 3 by 2, integral of x raised to 3 by 2 is x raised to 3 by 2 plus 1 divided by 3 by 2 plus 1. 3 by 2 plus 1 is 5 by 2. So x raised to 5 by 2 divided by 5 by 2. Limits 0 to 2. That is equal to, here substitute upper limit 2 raised to 3 by 2. Okay, 2 into, here it will be 2 into 2 by 3, that is 4 by 3. Okay, 4 by 3. This will be 2 raised to 3 by 2, that is 2 raised to 3 by 2. Okay, minus, next when we substitute lower limit, that is 0, it will be 0. Okay, minus, here put upper limit 2, that is 2 raised to 5 by 2. 2 raised to 5 by 2. Okay, before that we will write this 5 by 2. Denominator 5 by 2, that is 2 by 5, right? Okay, 2 by 5 into here 2 raised to 5 by 2. That is equal to here 4 by 3 into, see what is 2 raised to 3 by 2? That is 2 cube whole raised to 1 by 2, right? Or we can write root 2 whole raised to 3. That is equal to 8, 2 cube is 8, 8 raised to 1 by 2, that is root 8. What is root 8? Root 8 is nothing but root 4 into 2. Root 4 is 2. So 2 root 2. Okay. So it is 2 root 2. Okay. 2 root 2 minus here 2 by 5 into here 2 raised to 5 by 2. That is, see 2 raised to 5 by 2 can be written as 2 raised to 1 by 2, that is root 2. Root 2 whole raised to 5, that is equal to root 2 5 times. That means 4 root 2. Okay. So it is 4 root 2. That is equal to, here 4 into 2 8. 8 root 2 divided by 3 minus 8 root 2 divided by 5. We can take LCM. So here 5 into 8 40. 40 root 2 minus 3 into 8 24. 24 root 2 divided by 15. That is equal to 40 minus 24 16. 16 root 2 divided by 15. That is the answer. Integral 0 to pi by 2, 2 log sin x minus log sin 2x dx. Okay. So first of all, let's take it as I is equal to integral 0 to pi by 2, 2 log sin x minus log sin 2x dx. Okay, here also given definite integral is of the form integral 0 to a f of x dx. So we can apply the property. Before applying the property, here let's apply logarithmic rules. Here see, it's of the form n log x. What is n log x? N log x is equal to log x raised to n, right? So we can write it as integral 0 to pi by 2 log sin x whole square, that is sin square x, right? Minus log sin 2x. See, again it's of the form log x minus log y. What is log x minus log y? Log x minus log y is equal to log x by y, right? So we can write it as integral 0 to pi by 2 log of sin square x divided by sin 2x dx. That is equal to integral 0 to pi by 2 log of, here see the denominator sin 2x, we have an identity sin 2x is equal to 2 sin x cos x, right? So that one sin x will be cancelled. So here sin square x divided by 2 sin x cos x dx. Okay, that is equal to, here integral 0 to pi by 2, it will be, see sin x cancelled, remaining sin x divided by cos x. Okay, sin x divided by 2 cos x, that is sin x by cos x is tan x. So it will be log of tan x divided by 2, these two. Okay, then dx. Now let's apply the property integral 0 to a f of x dx, that is equal to integral 0 to a f of a minus x. Here in place of x we should write pi by 2 minus x. Okay, log of tan pi by 2 minus x divided by 2 dx. Okay, that is equal to, here what is tan pi by 2 minus x? Tan pi by 2 minus theta is cot theta, right? Okay, it will be cot x. So integral 0 to pi by 2 log of cot x divided by 2 dx. Okay, so what is it? I itself, right? So it's also I. See this I, it's also I, it's also I. So let's add these two integral. It is I, it is I. See, this one came from this one, that is I, okay, and it's also this one. So we will, when we add these two integrals, I plus I, okay. So I plus I, 2I is equal to integral 0 to pi by 2 log of, it is not this integral, this one, okay, tan x by 2. Log tan x by 2 plus log of cot x by 2, cot x divided by 2 dx, okay. Now, see, it's of the form log x plus log y. What is log x plus log y? Log x into y, okay. Log x minus log y is log x by y. Log x plus log y is log x into y. That is equal to integral 0 to pi by 2 log of tan x by 2 into cot x by 2. Okay, tan x by 2 into cot x by 2 dx. See, what is tan x into cot x? 1, right? Why? Because tan x into cot x is equal to, cot x is nothing but 1 by tan x. Tan x cancelled, that is 1. Okay, tan x into cot x is 1. Okay, that is equal to integral 0 to pi by 2 log of 1 by 2 into 1 by 2, that is 1 by 4. Log of 1 by 4 dx. Okay, see here log 1 by 4, that is, okay, log 1 by 4 is a constant, right? So we can take it out. Log 1 by 4 into integral of 1 dx, that is x. Now apply the limit 0 to pi by 2. That is equal to log 1 by 4 into pi by 2. Okay, pi by 2. So 2i is equal to this one. What is I? We need this value, right? So that is I. Okay, I is equal to log of 1 by 4 into pi by 2 divided by 2, that is pi by 4. Okay, pi by 4.